Okay, I'm going to do an example of a displacement versus time graph analyzing the motion. I'm looking at the blue note sheet that we had today with the displacement versus time graph, which is the same as the position versus time graph. And I'm on the back. I'm going to do this example right here, second down in the first column. So the first thing that I see is it is a distance versus time graph. And I'm going to write that down to start with. The D sets me off for don't sleep in class. Sleep stands for slope, and the C stands for curve. The slope, which is the first thing on this chart, is going to tell us the velocity. That's the first thing that we learned. So my velocity will come from this top row. And my acceleration information is going to come from this bottom row here. It's the second thing that we learned. Okay, so let's look at the slopes. The slope is changing from every single second for this one. So I can't look at just one slope. I can look at the slopes. If I take a tangent line to a particular spot, I could say that is the slope for this one little instance. I could draw another tangent line like this. I could draw another one that goes like this. All of those tangent lines have positive slopes. That's the same thing as saying the entire graph goes from down here, the lower the lower left-hand corner to the upper right-hand corner. So you can kind of connect the dots too. From here to here, that's a positive slope because the whole thing goes up. So I have positive slope. For a distance versus time graph, the slope tells us the velocity. That's why it's on the top row. So my velocity is positive, and positive velocity lets us know it's moving forward. Then I go look at the curve. And the curve, I have to look at the entire shape of the curve. It has nothing to do with whether the graph itself is increasing or decreasing. So I want to look at this curve and decide, is it part of up like a bowl or down like a mountain? And so this whole part is a portion of a down like a mountain. So that's down, and down like a mountain, your fingers point down. This is a negative acceleration. So you guys are, down is negative. So I have a down curve because it's like a mountain. And that means my acceleration is negative. And then the two of these together, because they have opposite signs, means that it's slowing down. So when you have opposite signs, they're working against each other. Velocity is already going forward, but then the acceleration is negative and it's taking away from it. So I can say that this object is moving forward and slowing down.